Hello physics fans, welcome to Exemplar Physics. Today in this video, we are going to understand the concept of work done in any thermodynamic process. I hope after this video, most of your doubts are going to get cleared. And at any point in the video, if you think that this video has helped you in any way, please like this video and subscribe to the channel. With this, let's get into the video. So first of all, let's write the basic definition of work done, which you must have studied in the chapter work energy power. There you must be writing work done as dot product of force and displacement, which can be expanded as F into S cos theta. That means you have to write the component of force along the displacement. This is what you are going to get for any general work. But in this chapter, we are going to deal with the gases, and that too gases enclosed in chambers. Here for simplicity, I have taken a cylindrical container for a gas. What gas are we going to consider here? We are going to consider here ideal gas, so that the things will be simpler to study. Now, what does this gas molecules inside the chamber do? They just roam here and there, undergo random motion, will collide with the walls of the container as well as the piston kept over here. So this is our piston. The gas has been enclosed with the help of a piston. I am taking here a frictionless piston, and we can apply force on the piston so that the gas inside it may get compressed or expanded. Now, these molecules also apply force on the piston because they are also going to collide with it. As a result, a force is always experienced by the piston from the inside. Now, let's try and think about what would happen to the forces we apply. So, if I apply force in the direction as in the figure, the piston is about to move in this direction. Let me show it with another color. The piston is going to move in this direction. So this is the displacement of the piston. But the force applied by the gas on the piston is in the opposite direction. So what is the angle between the force and the displacement? Force applied by the gas inside it and the displacement. The angle is going to be 180 degrees. Hence, here we can write Fs cos 180 is -1, so the work becomes negative. Now what if the gas applies force in this direction? Obviously it is going to always apply in this direction, and because of that force the piston also moves in the same direction. Then the angle between the force and displacement will be, both are in the same direction, hence angle between them will be 0 degrees, and cos 0 gives is equal to +1. So the work done over here is going to be Fs, but it is going to be positive. Now point to be noted here is the angle in any case is going to be either 180 degrees or 0 degrees. Therefore, the expression for work done is -Fs or +Fs always. If we think in a different way, here -Fs, when are we going to get -Fs? When the piston is moving inward, the gas is getting compressed, hence this will be the negative work done, and we call it as compression. And when the gas expands, when the gas applies force and the piston also moves because of that force, and this leads to what? The expansion of gas. Hence, during expansion of gas, the work done will be positive. I hope this small difference you have understood. When you apply an external force, gas gets compressed, the work done will be negative. When the gas applies force and the piston moves in the direction of the force, then it leads to expansion, work done is positive. Remember, both expressions are same. Fs in both case, but the sign is different. Compression, negative work done. Expansion, positive work done. If you have understood that part, now let's write the expression for the work done. For that, let me make some space over here. From now onwards, I'm just going to write the expression for work done as F into S. I'm not going to write positive or negative. You write positive or negative whether it is compression or expansion. So I'm not going to write any sign right from now onwards. Now the expression for work done becomes F into S. Now how to write force in terms of pressure? So if the pressure applied by the gas on the piston is P, then if the area of cross section of the piston is A is area of cross section of piston. Then this force can be written as the product of pressure into area, and thus displacement. If you see it clearly, the body has the piston has displaced by delta x. So this will be your expression for work done, but stop there. We are going to do more changes. What if I write P and A into delta x together? Now, what is this A into delta x? A is the area of cross section, delta x is the displacement. Now, this product leads to the volume of the cylinder which has been covered by the piston, or in another way, this can also be considered as the change in the volume of gas. This can also be considered as change in the volume of gas. How to write change in volume? Change in volume can be written as final volume minus initial volume. So what is the final expression we get for the work done? The final expression for work done is P into Vf minus Vi. Now check whether it is what the work done is positive or not. If it is compression, for compression, Vf will be always less than Vi. So Vf minus Vi is going to be negative. Hence the work done is negative. And for expansion, Vf is going to be greater than Vi. So Vf minus Vi is positive. So work done is positive. So simple as it is. Now I would also like to show this expression in the graphical form, which will make the task much easier. Now look at the graph over here. Let's clear it little bit. So I hope now it's very clear. Now check over here. What is P into Vf minus Vi? So what is Vf minus Vi? This is this distance. Let me show you here with the pen. Vf minus Vi is this distance. This distance is Vf minus Vi. And let's say this is the pressure. And what is this distance? This distance is your pressure. Now, if I do the multiplication of both P into Vf minus Vi, what I'm going to get? I'm going to get this area. So, what other conclusion can we bring here? This W is equal to Vf minus Vi is nothing but area under PV graph. So area under PV graph is going to give us the work done. Remember, if it is compression, negative. If it is expansion, positive. So if you have understood this, and here the graph is too simple, what if the graph becomes complicated as in the next figure? Now look at this graph. So here finding area is little bit difficult. The definition remains same. The area under PV graph is going to be a work done. So how to find that? For that, what I'm going to do is I'm going to divide this area into very small strips. Here, the width of the strip is dV, very small. And the pressure at this point, let us take it as P1. So what will be the work done? Since the strip is very thin, the volume is very small, the work done is also going to be very small. Hence, we'll write it as dW1. And as per expression, dW1 is equal to P1 into dV. Similarly, I'm going to take another strip just beside it with the same thickness. Now the new thickness is also going to be the same, that is dV again. And the pressure there, let us take it as P2. So now this is also going to give me small work. How much is it? Pressure there is P2, volume again is same, dV. Similarly, I'm going for the third strip. With the same width, dV, obviously the pressure is going to be P3. Now this is going to give me W3, which is equal to P3 dV. Now we are going to find out the work done starting from initial volume to final volume. Hence, we are going to get many such strips. And at the end, after doing this process, continuing this process to get net work done, we are going to add all these small works. And it's going to be a very tiring job. Hence, we are going to use the tool of integration. So by using the tool of integration, the expression becomes very simple. So instead of writing P1, P2, P3, I'm writing general P, where volume is going to change from VI to VF. The final expression for work done is integral of P dV from initial volume to final volume. Here also you are going to get the same, that is for compression you are going to get negative work, for expansion you are going to get positive work. I hope this has cleared the concept, and if you have done so, a big chunk of work has been completed. This is the end of the video. Thanks for watching, and don't forget to subscribe to the channel. I'm going to come up with many more videos like this. Keep supporting the channel. Bye bye.